Welcome to module 2, that is forecasting part 3. So in the part 2 we have discussed regarding different measures of forecasting accuracy methods such as mean absolute error or mean absolute deviation, mean square error, root mean square error, as well as a mean absolute percentage error. So in this lecture we are going to talk about the quantitative forecasting methods in which we have the historical data. So using that data we are going to predict the future. So in a quantitative, we have the two methods. Either we can apply the time series based forecasting method or the causal based forecasting methods. So these methods we are going to discuss later, which is basically the regression based methods. So right now we are going to start with the time series forecasting method, and more specifically in this lecture we are going to talk about the naive forecasting methods. So there are moving average based methods, we have exponential smoothing based methods, we have regression based methods, and then we have the seasonal adjustments based forecasting methods. But in this lecture, we are mainly talking about the knife based forecasting method, as well as we will discuss at what kind of data patterns this method is going to be appropriate. So first of all, let's discuss what is the knife forecasting. So the knife forecasting, as you can see, this FT plus one is basically that we are saying that we are going to predict one period ahead forecast. So this one is basically representing the forecast horizon. So that is basically we are going to predict one period ahead forecast. So the knife forecasting method is saying that the next time period forecast would be equal to the current period forecast method value. Okay, so which means the T plus month forecast would be equal to the actual demand of the Tth period, right? So this forecasting method is good when we only have the level pattern. Okay, if there is a trend and there is a seasonality, so we cannot apply this method. So we can use their adjustment parts, which we will discuss later. If we have a constant trend pattern or if there is a certain type of seasonality, then we can use those alternative part. But right now, this particular formula we of the night forecasting is only applicable and the good can be a one of the good forecasting method when we only have the level pattern, right? So as you can see from the formula, it is very simple to use, very simple to apply. So we can quickly prepare the forecast and it is easily to understandable. So now let's using a data set and try to apply the live forecast. Okay, like for example, if we have the monthly data and we have from January to February, we have the actual demand historical data, and we would like to predict the next year's January data using the live forecast. Okay, so as we have seen that the formula for the knife forecast is ft plus 1 is equal to at. Okay, so that means for the January we need the previous month data which we do not have. That's why we are going to skip this part. So in order to calculate the forecast value of the February using the knife, that is saying the previous month's actual demand, which is basically the 36. For the March, it is going to be 42, right? For the April, it is going to be 56. For May, it is going to be 75. For June, it is going to be 85, and so on. Similarly, for December, it is going to be 111, whereas for the next year, it is going to be 110, right? That is basically a one period ahead forecast value. So basically, nine forecasting method says for the next year, the January, the demand would be equal to 110. Okay, so these things we already know how to calculate it. So obviously this month is going to be skipped because we do not have the forecast. So in order to find out the error, what we are going to do is the actual demand, which is 42 minus forecast. Similarly, actual is 56 minus 42 and so on. Okay, and this is going to be 110 minus 1111. So again, we do not have this one, so we cannot predict estimate these errors. So we know how to calculate the absolute error. This is 42 minus 36, okay, absolute value and so on. And we know how to calculate the square. So this is going to be 42 minus 36 and square, and absolute percentage error. How we can do that? That is the absolute error, which is modulus of 42 minus 36 divided by the actual demand, which is 42 modulus multiplied by 100. Okay, so once we calculated this absolute error, error squares against the every value as well as absolute percentage error, and then after done this, we are going to sum this up, we are going to sum this up, we are going to sum this up, and we are going to divide it the number of data points. So right now the number of data point would be equal to 11 because this is the missing, this is also missing. So we are going to summing the 11 values. So sum it up divided by 11. This is going to be mean absolute deviation. Same is the case. Sum it up divided by 11. It is going to be mean square error. Sum it up divided by 11. It is going to be mean absolute percentage error. Okay. So let me apply this Naïve forecasting using one of the case study. Okay. So this case study I am going to use, and I am going to apply all the forecasting method on this case study data using Excel. So as you can see that this is basically a fashion wear company. Okay. So the Kamran Khan, who is the owner of, and the manager of the fashion wear. So basically, what he found that, so there is the problem with respect to the, if we are doing the over forecasting, if we are doing the under forecasting, as we discussed in part one, the same problem he is facing over here. So in order to deal the source of the problem, so Kamran requested that we should forecast and sales data based on the product category. So there is a two type of the product category. One is urban run, which is a athletic shoe. Another is a five pocket cargo jeans, which is from the apparel sector. So basically, the data set related to the urban run, that is in a table one, which is basically a quarterly data for the 4 years historical data we have. Similarly, we have the cargo jeans data, which is monthly basis of the 2 year data. So I right now for the to get the understanding, we are using this data set, which is basically the monthly data, and for the 2 years, which I have put this data into this Excel sheet. So this is basically, you can see that we have year of the 2 years and monthly, and then the data. Okay. In first of all, in order to apply any particular forecasting method, so as we have discussed in part one, we need to see the pattern of the data. Why the pattern of the data? Because we would like to see whether the data containing only the level pattern, or whether it is containing any trend or the seasonality. So how we can check? We can visualize the data pattern. How we can do that? We can use to draw the line chart. So in Excel, after selecting all the data set, we can go to insert, and then we can apply this line chart. Okay, this with marker. So as you can see that we have the years, we have month, and this is the basically the actual data. So although from this part we can see that there is an increasing trend, but overall onward, so we can see that we have only the level pattern over here. Okay, but right now I am assuming that the overall the data is the level pattern. Okay, so we are going to apply the naive forecasting method on this data. So how we can do that? So in this one, we know that in order to find out the February forecast, so for the January forecast, we are going to skip this one. So this is going to be equal to the actual demand of the January. So this is going to March forecast going to be equal to the actual demand of the February, and so on. Okay. So similarly, for 2020, the January's month forecast would be equal to the actual demand of 2019 December. Okay. and then we have applied the error, that is going to be actual demand minus forecasted value, and we can drag and drop right till over here. So similarly, in order to find out the absolute, we can apply equal ABS, which is the absolute function in Excel, into F5, which is basically the error value, and then we can drag and drop. Okay, so because based on this, we are going to calculate the mean absolute percentage error, okay, or mean absolute deviation. Similarly, we are going to find out the error square, so which is basically simply the square of this one, okay, and then we can drag and drop. Similarly, in order to find out this one, which is going to be the absolute error, which is 6 divided by the actual demand, okay, and then we can pick over here is that the result should be shown in terms of the percentages, okay. So once again, I'm going to skipping this decimal points, right? So in order to take the average, so we have applied in order to calculate the mean absolute percentage error, we have taken the average of uh, absolute percentage error. In order to calculate the mean square error, we have taken the average of the error square column. In order to take the mean absolute deviation, we have find out the average of the absolute error. Okay, one thing as we have studied while we were discussing these mean measure of forecasting accuracies is lesser these values, better the forecasting method is. But right now, can we rely on this Naïve forecasting method? Remember that on one single data, you always apply two or three methods, which mean multiple forecasting methods, and you will compare which forecasting method is producing the smaller error. That particular method is going to be the appropriate method for this particular data set. So as we are going to use the same data set and we are going to apply the multiple forecasting method, so when we will apply all the methods on this data set, and at the end we are going to compare which method is the best method for this particular data set, right? But right now we have predicted using the Naïve forecast technique or the forecasting method. The value in 2020 January is going to be 102. So if I would like to draw this one, so I can use this these values, so including the forecasting value. So once again I am going to insert, and then I am going to click line mark, okay, and you can see that we are having this forecast value. So this value is indicating the brown color is indicating the Naïve forecast value, the blue is basically the actual demand, okay. So I hope you got the idea how we can apply this Naïve forecast in the Excel. If I go back, okay, now, if our data do contain some trend component, okay, which is the constant, like as I'm saying that if our data is that is increasing or increasing 10% or maybe decreasing 10%, so that means this is the constant increase every time period. So what we will do, in order to predict, we are going to take the current period forecast, which is let's say 100 unit, and then whatever this particular value is, we are going to take that constant increase or decrease. If the increase is 10%, so the 10% of 100 is going to be 10, okay. So that increase plus the constant value, which is going to be, that means the next period forecast is going to be 110. But if the trend says there is a decreasing part, then we are going to, instead of addition, we are going to subtract. So that would be equal to the 90 would be the next period forecast. Okay. So, but right now we have taken that there is an increasing trend. So that's why we are adding 10 into the 100, which is 100 was the current period forecast, so the next period forecast would be equal to 110. And then if we are saying that if there is a seasonal component which is known as seasonal Naïve forecast method, then it is saying that the last year's that particular month value would be equal to same as for the next year's same month value, which means if we are saying in 2019 January, the value was 120. So it is indicating that in 2020, the January value would be equal to 120. If the February value in 2019 is 220, so that means according to the seasonal life forecast, it is going to be 220 for the February and so on. Okay, so I hope you got the idea. If there is a trend component, how you are going to deal in with the help of the night forecast method. If there is a seasonality component is there, okay, then how you are going to deal this one. Okay, so thank you so much. See you in the next video.